So we are dealing with this problem which is came in paper 2 Jee Advanced 2025, and the problem will be dealing with multiple concept applications. Especially the problem is based on projectile motion. The motion is suggesting, or the question is suggesting, a projectile of mass 200 gram is launched in a viscous medium at an angle of 60 degree with the horizontal with an initial velocity of 270 meter per second. It experiences a viscous drag force F vector equal to minus CV vector, where the drag coefficient C is equal to 0.1 kg per second and V is the instantaneous velocity of the projectile. The projectile hits a vertical wall after 2 seconds, taking E as 2.7. The horizontal distance of the wall from the point of projection will be. So let's get started with the problem. We will first of all draw a diagrammatic situation to understand the problem. So we can understand it graphically like this. So this is the things that are going on. This is the point of projection from which this projectile is projected with a speed u at an angle theta, and in the usual case it will be moving in this 2D plane like this and then maybe land somewhere here. But in this scenario over here we have a vertical wall, and if at an instant of time the projectile is having a velocity v with two components vx and vy, only gravitational force will act on the projectile in normal cases. But over here in this particular problem, a drag force is going to act which is minus CV vector. So we can say that a component of drag force is going to act in this direction opposite to the direction of velocity. So opposite to the direction of velocity, a drag force is acting, and this drag force will have its component in the x direction. So a drag force component in the x direction and a drag force component in the y direction. So the drag force is going to have two components in the x and y direction, and after some time the projectile is colliding with the vertical wall, and the time duration is mentioned to us in the problem as t equal 2 seconds. And the problem is asking us to calculate the horizontal distance which this particle covered from the point of throw before striking the vertical wall. That is, we need to determine the displacement along x-axis. So now let us break the component of the velocities, identify the forces along x-axis and solve it along x-axis. We need not solve along y-axis because there is nothing to solve in the y-axis direction. The problem would have become more tougher if the problem would have suggested that if it collides with the vertical wall at the highest point of its trajectory, तो फिर अपने को y के along भी solve करना पड़ता to find out कि कब velocity zero हो जाएगा y के along, और फिर अपने उस टाइम को पुट करके तो फिर ये निकालते. लेकिन खैर क्वेश्चन में ऐसा कुछ नहीं बोला, तो क्वेश्चन में सिर्फ x के along solve करने से काम चल जाएगा. So let's get started. We are trying to understand along x-axis. So let us start identifying the components which we are looking for. So the initial velocity in the x-axis will be u cos theta component, and we know u and cos theta both, so we technically know everything about this term. Displacement along x-axis is something we need to solve in the problem. Time 2 seconds, so again we know about it. So we can say for the time being that we will take it as t, and then later on we will substitute 2 seconds over there. And acceleration along x-axis. So along x-axis there is no component of gravitational force that is acting. So only drag force is acting in this direction, which is equal to minus CV, and we can divide this by m. But it must be noted over here that it is not constant. So acceleration is not constant but a function of velocity. And at an instant of time, if the velocity is Vx, so then we can say something like this, that dVx by dt is equal to minus cVx by m, where v is the component of velocity Vx along x-axis. And now let us only focus on solving this particular equation which we have. So we can write it as dVx upon Vx is equal to minus c by m dt, and then we integrate both sides. So we are integrating from a time t equal to 0 to a time t from velocity which we have taken as ux to a certain velocity, let us say u. So we are solving an expression like this to obtain a condition for velocity. So over here we can write it as ln of v by ux is equal to minus c by mt, and hence the velocity equation will take the form v equal to ux e to the power minus ct by m. Now we need to solve for displacement. So if we write v as ds by dt, so displacement along x with time dt, then we can write it as ux e to the power minus ct by m. So now next is displacement along x axis can be solved from this equation e to the power minus ct by m dt, and then integrating both sides. So from t equal to 0 to t, which is 2 seconds, and from 0 to displacement along x axis. So from here we will take this form as ux e to the power minus ct by m divided by the coefficient, that is minus c by m, and then we are solving it from 0 to t, which is 2 seconds. So now if we substitute the values, so let us first of all calculate for c by m. So c is equal to 0.1, which is given in the problem, and m is 200 by 1000, that is 0.2. So c by m is half, and we have t equal to 2 seconds. So if we will be putting this value 2 seconds over here, and then we have half, so we will be left with e to the power minus 1, and over here we will be left with half. So technically we can say that in the end we are going to obtain something like this: twice of ux 1 minus 1 by e. Now if we put the value, so twice of ux, so ux we already had 270, and cos theta component will reduce it by half, and then we are again multiplying it by 2 to restore the value 270, and then we have e minus 1, that is 2.7 minus 1, 1.7 divided by 2.7, and on solving we obtain 170 meter. So this is how you solve this particular problem, where the concept of projectile motion is mixed with the concept of drag force, and this was 15th problem of Jee Advanced 2025 paper 2.